Okay, just going to go through question 1 from exercise 10F. We've got two particles, A and B, of masses 4 kilograms and 3 kilograms respectively, connected by a light inextensible string which passes over a small smooth fixed pulley. Particles are released from rest with a string taut. Find the tension in the string. So, if that's 4 kilograms, that's 3 kilograms. That's going to fall that way with an unknown acceleration, and that's going to be dragged up with the same unknown acceleration. And for part A, I'm going to resolve each particle one at a time. So resolve A only. Force is acting on A, has a weight, 4g newtons. It's attached to a string, so there's going to be a tension, T newtons. It's accelerating, so F equals ma. The mass of the object is 4, acceleration of the object is a. Force is going with the motion, subtract the forces going against the motion, you get this equation. 4g subtract t equals 4a. And let's try something similar with the other particle. Force is acting on this object. It has a weight, 3g. It has a tension, T. It's accelerating, so F equals ma. The mass of the object is 3, the acceleration of the object is a. Force is going with the motion, subtract the forces going against it, you get this equation. Equation 1, equation 2. Two equations, two unknowns, you can solve them simultaneously. If you add them together, the t's cancel. 4g add negative 3g is 1g. 4a plus 3a is 7a. So the acceleration is 1/7 g meters per second squared. Let me just check, that might have been part B. No. Okay, part A still is work at the tension, so T would be equal to, sub it back into this one, 3/1/7 Gs plus 3 Gs, which is equal to okay, what's 3/7 plus 3 first? So it's either 24/7g newtons, or if you prefer, times that by 9.8, 33.6. And that would be part A. Part B says, when A has travelled a distance of 2 meters, it strikes the ground and immediately comes to rest. Find the speed of A when it hits the ground. So A is going to fall, hit the ground, distance 2 meters away. So it sounds like a Suvat question to me. So part B, Suvat. S is 2 meters. It's initially at rest, given in the question, so U is 0. B is the thing you want to work out. And acceleration, I've just worked out to be 1/7 G. Time is unknown. And V squared equals U squared plus 2AS. V is unknown. 0 squared plus 2/1/7 Gs times by 2. To give you V squared is wherever 4/7 G is, or V is equal to square root of 4/7 times 9.8 gives you this, 2.37 meters per second to 3 SF. Part C, assuming that B does not hit the pulley, so if you look at this diagram, A is going to fall 2 meters, B would have to be pulled up 2 meters, but it's not going to hit the pulley. Find the greatest height that B reaches above its initial position. So, when A hits the ground with a speed of what we just worked out to be 2.37 meters per second, B gets pulled up and its speed there is 2.37 meters per second, but when particle A hits the ground, the string becomes slack, i.e. there's no tension in it, which means the only force acting on B would be its weight. So when it's at a speed of 2.37 meters per second, it will continue to move up, but it would decelerate due to gravity. So it's another suvat, but when the string is slack. So part C is suvat. Remember, we're going upwards. So S is unknown, and the thing you want to work out. U is 2.37 meters per second, or that long decimal. I'm going to use the exact answer. V, the final velocity, would be 0 at its greatest height. And because the string is now slack, the acceleration is negative 9.8. And T is unknown, I don't care about it. So you've got V squared equals U squared plus 2AS. To give you S is equal to, if we made S the subject, 0 squared subtract 2.37 squared, use the exact answer, over 2 times 9, negative 9.8. So 0 squared subtract my previous answer squared over 2 times minus 9.8 gives me 2/7. So A falls down 2 meters, hits the ground. B goes up 2 meters and then goes up an extra 2/7 meters. So wanted to work out the greatest height that B reaches above its initial position. So greatest height equals the 2 meters it moves when it's connected plus the extra 2/7. So we'll go with 2.29 meters to 3 SF. And that would be it.